Hello students, problems in circles chapter are often challenging because it requires students to apply concepts not only from this chapter but also other topics that you have learnt in 10th standard. Here we have one such example. Let's see how to solve this question. Okay. A circle with center C has radius 7 cm. Tangents are drawn to this circle from an external point P such that PC is 25 cm. The tangents touch the circle at points A and B. Find the length of chord AB is the question that is asked. Okay. Now to start with, let's see what is given in the question. Well, we know that there is a circle, okay, whose center is C and whose radius is 7 cm. Okay. Now we are given that there is an external point P such that PC is 25 cm. Okay. Now we are going to draw tangents PA and PB. Okay. And the chord AB's length is what is asked. Okay. Now we need some construction to solve this question. The first one is to simply join CA. Okay. And we can recognize that CA is also radius, therefore that is also 7 cm. Now we also know that the radius is perpendicular to the tangent at the point of contact, therefore this angle CAP is 90 degrees. Okay. Now we have some information to proceed with solving the question. Okay. So the first thing is to consider triangle ACP. Now it's clearly a right angle triangle because there is a 90 degree angle. Okay. Now therefore we can apply Pythagoras theorem and we can write PC square is PA square plus AC square. Okay. Clearly PC is the hypotenuse because it is opposite the 90 degree angle. Now we know that PC is 25 cm. So we can substitute here as 25 square equals PA square plus AC is 7. So you will get PA square plus 7 square. Okay. We can simplify this as PA square equals 25 square minus 7 square equals 625 minus 49, which is 576. So PA will be root of 576, which is going to be 24 cm. So let's mark PA as 24 cm. Okay. Is that all? No, we have just solved for the length of the tangent. But the question that's asked is the length of the chord AB. Okay. So how do we proceed now? Well, first let's look at chord AB and see where it's cutting this line CP. Okay. So let's mark that point as E. Can we say something about E? Well, if you consider these two triangles, which triangles? Triangle APE and triangle BPE, they will be congruent. Okay. It's not very difficult to prove because we have already proved earlier that PA and PB are equal. Remember, tangents from an external point are equal, and in that proof we would have also shown that these two angles are equal. So with that, with SAS you will be able to show congruence. Now what this means is that AE and EB are equal and also these two angles are equal. That means each angle must be 90 degrees. It's not too hard a proof. Okay, you can derive this easily. So a conclusion is the angle here is 90 degrees. Now this is going to be very, very important for us to be able to solve this question. Okay. Now we said in the beginning that this problem has applications from other ideas too. What is that other topic? Well, that is trigonometry, and with trigonometry we will be able to solve this much more easily. Okay. For that, what we are going to do is we are going to mark this angle as theta. Okay. Now we have triangle ACP, right? So in triangle ACP, we are going to write sin theta is opposite by hypotenuse. Opposite is AC, hypotenuse is CP. Okay, now we know that that is 7 and this is 25, therefore it is 7 by 25. But this angle theta is also part of another triangle. What is that triangle? Triangle APE also has the same theta, and that is also a right triangle. Therefore, we can use trigonometry and write sin theta equals, now opposite by hypotenuse is, opposite is AE, hypotenuse is AP. So, it's AE by AP, which is AE by 24. Now, look at these two expressions. Both are the same sin theta, it's the same theta, and that means these two ratios have to be the same because it's talking about the same sin theta. So, we can conclude that 7 by 25 equals AE by 24. That means AE is 7 into 24 by 25, which is 168 by 25. If we want, we can write it in decimal as 6.72. But that is only AE. We want AB. But remember, we already showed that AE and EB are equal. That means what? That means AB is nothing but 2 times AE, and AE is already computed. So, it's 2 times 6.72, which is 13.44 centimeter. That is the length of the chord required for us. Okay. Now, we have solved for the question, but there is one other point that we have to keep in mind, which is that instead of trigonometry, we could have also arrived at the same relation using similar triangles. You've also learnt about AA criterion in similar triangles, and that could have been used to arrive at the same equation. But again, that's also a topic different from circles. So, you could use trigonometry or you could use similar triangles to arrive at the same answer. So, the required value of the length of the chord is 13.44 centimeter.